So you should have ended up with the 3 more, 5 pi over 9, 11 pi over 9, and 17 pi over 9. So how many angles in total did we come up with this solution? 6. And how many in the beginning did I said to be on the lookout for? 6. Because you had 2 angles in the beginning that we looked at, and then we had that coefficient of 3. So that kind of gives you a red flag to be prepared of how many solutions you're probably going to be using. Yes? It could be in certain situations, but at least that kind of gives you something to be on the lookout for. Okay? The zeros and ones, when you have the zeros and ones and quadrantals, that's where it may be different. Okay, let's take a look at another one. Number 3. First of all, cotangent of 3 theta plus square root of 3 is equal to 0. Is this my good news or bad news situation? Good news, because again, I know that when I rewrite this as the cotangent of x plus square root 3 is equal to 0. How do I solve this? What's going to be my first step? What's my first step to solve this here? What am I going to do to get cotangent by itself? Subtract square root 3. If you're not sure where cotangent is equal to negative square root 3, cotangent is reciprocal of the tangent. So I could take the reciprocal of square root 3, which would be negative 1 over square root 3. Which when I rationalize negative 1 over square root 3, that's equivalent to what? Negative square root 3 over 3. So now where is tangent negative? What quadrants am I looking in? 2 and 4. So what's the angle in quadrant 2 that has the tangent value of negative square root 3 over 3? 5 pi over 6. And the one down here in quadrant 4 would be 11 pi over 6. When you're doing the tangent, you want to pick it up, use your smallest angle. So again, what was x equal to? X was equal to 3 theta. So it's going to be 3 theta. Write your generalization. It's going to be 5 pi over 6 plus or minus what? Is it going to be plus pi k or plus 2 pi k? Pi k. Now some books or standardized tests may use a different letter than k. Some may use n. So again, if you see a question like this when you're taking a standardized test and you see an n or something like that, don't be alarmed. We're just calling it k. Okay? So now how do you solve for theta here? This is what are you going to do here? To solve for theta, what are we going to do? Multiply by 1/3. So theta is going to be equal to 5 pi over 18 plus pi k over 3. How many solutions do you think we should be on the lookout for? 6. That's possibly a good number of what we're going to be, so just be prepared for that. Again, like what I like to do is just look at my pi over 3, because I know I'm going to be adding fractions, get that denominator, the common denominator to begin with. So how can I write pi over 3 with a denominator of 18? Pi over 3 is going to be equivalent to 6 pi k over 18. So now you can start generating your list. Start with 0. So when k is equal to 0, 5 pi over 18 plus 0 is just going to give you 5 pi over 18. Now plug in a 1 for k. So again, when k is equal to 1, I have 5 pi over 18 plus 6 pi over 18 times 1 is a 6 pi over 18. So what's 5 pi over 18 plus 6 pi over 18 going to be? 11 pi over 18. There's my second angle. Where am I going to get to? When can I stop? 36 pi over 18, because that's where you'll hit 2 pi. So that's k is equal to 1. So now k is equal to 2. 6 pi times 2 will give me a 12 pi over 18. So 5 pi over 18 plus 12 pi over 18. So what's 5 pi over 18 plus 12 pi over 18? 17 pi over 18. Remember, once you take it out 3, see if you notice a pattern. Do you notice a pattern in the numerator? Yes, it's going up by what? 6. So what's the next angle going to have to be? The next angle will be what? 23 pi over 18. The one after that will be what? 29 pi over 18. And the one after that will be what? 35 pi over 18. Can I stop? Yes. How many answers did I end up with? 6. And then I said that's probably what we're going to be on the lookout for in the beginning. Yes, Marissa? No, always take it out 3. Always take it out 3 to assure that the pattern. It doesn't, sometimes there are those rare cases where you take it out that third case and it's going to be different. So always take it out 3 to confirm it. Okay? So any questions on the third one? Take a look at the fourth one. Yeah, I'm sorry.
No, I have a question about why you have to take it out 3 times, because isn't it just the coefficient of the pi and the constant?
Always take it out 3. Trust me.
Okay.
I mean,
In what cases would it not?
Sometimes there's always those goofy cases, especially if you end up with a fraction in there, which sometimes happens, like a 3/4 or something. Always take it out 3 to confirm it. Okay, just to be a safe rule of thumb. I'm going to agree with you. Most of the time, you'll notice it in 2. Most of the time. But in math, as you know, there's always those rare exceptions to the rule. All right, so just always take it out 3. It doesn't take that long to take it out that third time, just to be on the safe side. Okay? Any other questions on that? Look at number 4. Is this my good news or bad news scenario? Bad news. Why is it my bad news? Because it's sine. Why in this case do we not like sine? Yeah, why? How come we don't like cosine? I'm sorry. Because what's going to happen? We have to do what? Both. So notice I'm going to get a fresh new sheet of paper. 4. So we have 2 times the cosine of 4 theta plus 5 is equal to 4. That is a plus 5, yes. Again, let's start getting cosine by itself. What's going to be my first step? Subtract 5. So we have 2 cosine of theta, 4 theta, is equal to -1. Then what? Divide by 2. So cosine of 4 theta is equal to -1/2. Again, unfortunately, ladies and gentlemen, we've got this 4 in front of theta. So this is when we know we're going to have to write our generalizations. So again, I'm just going to rewrite this. Let's let x be equal to 4 theta. So first I have to figure out, well, where's cosine of x equal to -1/2? So what 2 quadrants am I looking in? 2 and 4. So what's the angle up here in quadrant 2? 2 pi over 3. And the one down here in quadrant 4 will be?
Wait, I'm confused.
It should be 2 and 3, you're right. Let's make sure you're awake. 2 pi over 3, and where else? 4 pi over 3. Yeah, cosine's negative in 2 and 3. So we good so far? So now, like you mentioned, this is your bad news situation. Because you are going to have to consider both your 2 pi over 3 and 4 pi over 3. So what I usually do in the beginning is I set up my 4 theta is equal to 2 pi over 3. And what is my generalization for cosine? Is it plus or minus pi k or plus or minus 2 pi k? 2 pi k. And then I know I'm going to have to do 4 theta is equal to 4 pi over 3 plus or minus 2 pi k. That's just a reminder in the beginning that I'm going to have to do both. So let me work on 2 pi over 3 first. So what's going to be my first step here to get theta by itself? I'm going to divide by 4 or do what? Multiply by 1/4. So theta is going to be equal to 2 pi over 12 plus or minus 2 pi k over 4. Can you reduce your fractions? Yes. So any questions on how I solve that for theta? Now again, like I like to do this in the very beginning. Let me rewrite pi over 2 with the denominator of 6. So I know that that would be 3 pi k over 6 is equivalent. So let me start by generating my list. Start with k is equal to 0. Well, if I plug 0 in for k, 0 plus pi over 6 will give me what? Pi over 6. Where am I going to be able to stop? Where am I going to be able to stop? When will I get to angles greater than 2 pi? 12 pi over 6. So kind of always know when you can stop. I always like to kind of know where my stopping point is going to be. So now plug in 1 for k. So I have pi over 6 plus 1 times 3 pi over 6 is 3 pi over 6, which will give me 4 pi over 6. I always wait to reduce fractions after I'm done generating my list. Next I have when k is equal to 2. So when k is equal to 2, that's going to give me pi over 6 plus 6 pi over 6, which will give me 7 pi over 6. The reason why I always wait so I can notice that pattern. What's that numerator increasing by? 3. So again, my next one's going to be 10 pi over 6. The next one would be what? 13 pi over 6. So I'm done. So I know that I've got 4 answers here. Pi over 6, 2 pi over 3, 7 pi over 6, and 5 pi over 3. How many answers do you think we are going to end up with? 8. 8. I got 4 out of my 8. And if I'm going to guess correctly, it's probably going to be all those members of the pi over 6 and pi over 3 family that I did not get from this side. But again, let's double check it. So I'm going to multiply this by a 4th. So I end up with theta is equal to pi over 3 plus or minus 2 pi k over 4. So theta is going to be equal to pi over 3 plus or minus pi k over 2. So any questions on how I solve this for theta? Now, what's the common denominator going to be between 3 and 2? My common denominator is going to be a what? 6. So this is going to be a 2 pi over 6 plus or minus 3 pi over 6k. So go ahead and see if you can generate the other 4. Again, like I have a feeling it's going to be all the other pi over 3s and pi over 6s. But again, just practice that k value, plugging in those k values. Make sure you're good with that. So if they ever ask you guys just for the general solution to find all angles, that's it right there. So this is your generalization because this is the formula you are using to help you calculate all the answers. So when they ask you for the generalization or the formula that you're using to come up with all solutions, that's it right there when you solve for theta. Because that's the formula that we can use to generate every single solution. So if they ask you to find angles up to 4 pi, you would just keep plugging numbers in for k. Or if you have that pattern, you can just increase that numerator. Aren't these fun?
You asked us for the generalization on the test.
Could be. Why do you think I'm circling it and pointing it out? Actually, if I ask you just to tell me the generalization, isn't that better than me asking you to find the specific angles between 0 and 2 pi?
Yeah, that's why I was asking.
Yeah. So actually, if I ask you for the generalization, that should be even great news. That even beats the good news, bad news scenario. That's actually great news.
It's all bad news.
So as you can see, guys, you ended up with all the other pi over 3 and pi over 6 angles from the unit circle. All right? So like I said, this is a case where sine, cosine, secant, and cosecant is going to be your bad news. This is a case where you're actually going to like tangent and cotangent better than sine and cosine. All right? Let's take a look at, let's do a secant. Let's take a look at number 6. Okay, so again, you've got that theta with a coefficient of 2. We have to get secant by itself, so what's going to be your first step? What's going to be your first step here to get secant by itself? Divide by 2 square root 3. So I have secant of 2 theta. 4 divided by 2 square root 3 is going to give me 2 divided by square root 3. Well, secant is reciprocal of what? Secant is reciprocal of the cosine. So I could rewrite this as the cosine of 2 theta is equal to the square root of 3 over 2. Now, you do have the double angle formula for cosine. However, unless it's a matter of you being able to do any kind of factoring, you're going to have to use, it's easier to use your generalization. Because even if I did a substitution of the cosine double angle formula, that square root of 3 over 2 and adding 1 to it or doing whatever is going to make it ugly. So that's why in this case you're better off doing your generalization. So just because you see that cosine of 2 theta, you can try it, but it's not going to be as pretty as doing the generalization. By the way, is this going to be my good news or bad news scenario? Bad. Why is it going to be bad? Because it's a cosine, which means I have to do both. So I need to find where is cosine of x equal to square root of 3 over 2. So where's cosine positive? Let's see if Mrs. Berge can remember where cosine's positive. Cosine's positive where? 1 and 4. Very good. So my angle in quadrant 1 that has a cosine value of square root 3 over 2 is going to be at pi over 6. Down here in quadrant 4, it'll be 11 pi over 6. How many answers do you think we're going to come up with? Perhaps? 4. So I'm going to bring my 2 theta is equal to pi over 6 plus or minus, is it going to be 2 pi k or 4 pi k? 2 pi k. And again, I just like to write for the second angle as well. 2 theta is equal to 11 pi over 6 plus or minus 2 pi k. I just like to write them both in the beginning so I don't forget to do them both. Once I identify this is my good news, bad news scenario. So how do I solve for theta here? What am I going to divide by or multiply everything by what? 2. Divide by 2 or multiply by a half. So theta is going to be equal to pi over 12 plus or minus 2 pi k times a half will give me a pi k. And that common denominator is going to be a 12 pi k over 12. Where am I going to be able to stop? Where can I stop this generating this list? 24 pi over 12. So let's start with when k is equal to 0. So when k is equal to 0, 0 times this will go to 0. So my first angle is going to be pi over 12. When k is equal to 1, what is 12 pi over 12 plus pi over 12? That's going to be a what? 13 pi over 12. And again, if I plug in 2 for k, you told me to stop at 24 pi over 12. If I plug in 2, well, I know 2 times 12 is 24. So I know these are the only 2 angles between 0 and 2 pi for this part of the... So now I have to consider the second angle. So I'm going to multiply everything by a half. So theta is going to be equal to 11 pi over 12 plus or minus, again, 2 pi k times a half is going to give me a pi k. And again, I know that this is 12 pi over 12. So what's the first angle from this list going to be? The first angle will be what? When I plug in 0 for k, what's that going to give me? 11 pi over 12. When I plug in 1 for k, 12 pi over 12 plus 11 pi over 12 is going to give me a 23 pi over 12. And I know I don't need to go any further. So like I mentioned before, we said in the beginning, how many angles should we be on the lookout for? 4. Okay? Let's take a look at number 8.
Oh, it's a bad one.
Is this my good news or bad news scenario? Bad. So what's going to be the first step to get cosine by itself? I'm going to do what? Divide by 2. So cosine of theta over 3 is equal to square root of 2 over 2. Now, just because you see a theta over 3, do not be alarmed. You're still going to take that theta over 3 and set it equal to the angles that you get. What quadrants am I looking in? I'm looking in 1 and 4. So what's the angle in quadrant 1 going to be? Pi over 4. The one down here is going to be 7 pi over 4. So what I have to do is take theta over 3, set it equal to pi over 4, plus or minus. Is it a 2 pi k or pi k? 2 pi k. So just because it's theta divided by 3, what am I going to have to do here? I'm going to have to multiply everything by what? 3. So theta is going to be equal to 3 pi over 4 plus or minus 6 pi k. Actually, these turn out to be, when you see the division, you end up with fewer answers. So then, what's the only solution you're going to get from this one angle? When I plug in 0 for k, the only angle is going to be what? 3 pi over 4. Do I need to go any further? No, because it's adding 6 pi. So you only have the one answer here. And then you have the theta over 3, set it equal to the 7 pi over 4, plus or minus 2 pi k. Now what happens, guys? Shh, nobody should be packing up. Theta is equal to 21 pi over 4 plus or minus 6 pi k. Do I even have to consider 21 pi over 4? No, because it's already greater than 2 pi. So you only have the one answer. So like I said, when you see the division problems, those aren't as bad as the other ones.